is the project to implement the shared program. So, what is shared programming? It's the interface, the terminal interface. So in other words, using the shared programming, like for example, batch shell, you are able to what? You can do whatever. Whatever means, in terms of operating system, the only way to use your computer is what? Creating process. Through the process, you are able to use computing research. So at that time, you can use the shared programming. In this project, you are going to develop your own shared programming. It's not very simple, but I believe 90% are the same as the existing shared programming. So main job of shared programming is what? Create process. That's it. So in your first step, in your project first step, you are going to create the process here. Fork or child process, then exec command, then what happened? Wait until your child process is done. Then you need to do wait the next command. So this is a skeleton program of your project 1. That's simple. Okay? How do you create? We already saw the example. So it's but depending on the system library, operating system, they may use different, like instead of exec, sometimes repeat, figure out what's the difference. Some of them are free fork, some of them are free exec, some of them are exec. They are mostly similar, but slightly different purpose. But you can figure it out. So then find the proper the system library, fork, and exec, and wait. The 3 of them are the major, the system library you need to use. Then, depending on what is the command, like you can read the command using argument, like the parameter, like if you start your program like the a.out, ls, this is the argument. Okay, so you can read such an argument, then use this one for the exec. Then that's it. That is the first, the part A. Okay, so part A. This is just an example of what you need to do. Okay, then the next part will be additional feature. Okay, you can make the add additional feature like the process selection. Instead of typing, you can select the program that you are going to execute. So to do that, so this time I'm going to restrict your implementation in the GCP. So using GCP compute engine that you create. So using the GCC compiler or the C++ compiler. So there's no graphical user interface here. Okay. GUI, I don't care. So it's not easy even to implement the GUI-based the shell. So just a command line interface. So you can use a lot of printf. Okay, just print out the output or the input for the communication. Then to do that, C or C++. Plus, if you are able to use a Python will be allowed. So Python is actually not using directly the system library. However, it pretends the system library, like it provides the fork and exec style. You need to mention in your documentation in the Perl program, I'm using this command, this library package for the fork and exec. Java is not accepted. We will discuss why Java is different from the other program languages during the chapter 4 thread. Okay, if you want to use the other program languages, other than the C, C++, Python, definitely the Java is not accepted. But the other program languages you want to use, contact me. Okay, before you start your program, I will take a look at the main purpose of the programming assignment project is to get used to use the system library, okay, and understand the shell programming. So that is the main part. I don't expect the fancy, nice, the professional, the programming. So it's not programming class, okay? It's the operating system, whether you are able to implement the algorithm or the definition that we discussed in the classroom. That is the main purpose. So even though you do not know much about the command line, the GCC compiler for the C, it's not a big deal if you already took the C++ class. Okay. Any question regarding to the project? You will get more information in the exercise we will have the first exercise, Unix programming, the Wednesday and next Wednesday. You will learn more about this one. And we have a couple of more minutes, not yet. What is a program? Program. Sequence of instructions. So we have the instruction. Sometimes move, sometimes the shift, sometimes the add, or the so on. We have the sequence of instructions, assembly, language. Then, when we create the process, this one will be loaded into the memory text area. So this one will be copied. Okay, then CPU can read using the PC program counter, find the location in the memory. How do you find? Address. It's nothing but address. A lot of time move. That is a reason move. The assembly command use the 60% or 50% of any the programming code. Then, problem. Think about the Chrome. So how many programs can we find regarding to the Chrome? One program, right? One program, one sequence of instruction. This is called thread. Okay? Thread is the thread. So we use such a name of thread to represent sequence of instruction. Then sometimes the Chrome use this one as another process. This is another process. This one is another process like this. Several threads are executed same time. Okay? Then, why don't we think instead of creating multiple processes? So, sometimes when we load all the instruction into here, we are going to share the resource like the global variable. Global variable is global, right? It can be accessed by any location of your program. Then, temporary space may not. But this one and this one, instead of creating multiple processes like the Chrome, why don't we share this one? Then only the local variable or local part of the data we are going to create in the memory like this. Instead of creating new processes, this much for multi-process, okay? Because they are the same. We don't have to load it again. Instead, only specific part. And global variable, we are going to share global variable. And some local variable or the dynamically increase the data, like temporary data, we will create a small version of the process. So this is called thread. Thread is called the threading. So it's kind of lightweight version of a process, but it's not the same as the process. So, in terms of performance, which one will be better? Definitely, this one is better. So, for example, think about the creating thread. It takes, for example, 30 milliseconds. Then, this one usually takes 1 millisecond. Because it's a small amount of the programming code, thread part. So, this part only. So, it's in terms of performance, better. The problem, they need to communicate, and anyway, all of this will belong to one process ID. So management issue. So Java uses this kind of thing, which means when you run the Java application, it will be loaded into where? Java virtual machine. the reserved area to manage such a thread. They do not create the process separately. Okay? Instead, they manage such a light version of the process, which means the thread in this area. So, next class we will talk about the details of this data structure. Okay, any question? Okay, thank you, and we will please bring your laptop because we will have the